Hello, my name is Armāns Kviesis and I'm from Latvia University of Life Sciences and Technologies. And today I would like to talk about one of the SAMS Hive monitoring systems. At the core of this system is a Wi-Fi microcontroller, which is perfect for IoT applications. And basically what a microcontroller is, it can be considered as a very small computer that's placed on a single integrated circuit, and it is dedicated to execute one specific task. This ESP8266 microcontroller is a very powerful processing unit and can achieve quite less power consumption. And the power-saving architecture that is also integrated within this chip allows it to be used in battery-powered solutions. Here you can see a very rough block diagram of the ESP8266 microcontroller, which shows you the Wi-Fi module, the peripherals, the core itself, some real-time clock. But what happens when this microcontroller is put into a deep sleep mode? Basically all of the modules are powered off except the real-time clock. And since the real-time clock also has some memory, it allows to preserve some data during the deep sleep. And here you can see the custom printed circuit board that was designed within the SAMS project, where on the left side is the board itself, but on the right side is the completely assembled monitoring system with all the necessary electronic components and modules. But what does the monitoring system actually measure? Within the SAMS, this monitoring system measures temperature, humidity, weight, and besides the Hive related parameters, it also measures the voltage of the power source, so we can remotely see what is the voltage level of the batteries. Besides the printed circuit board, we also designed a protective casing for the electronics. The monitoring system's power consumption was also evaluated, and here you can see the current consumption per measurement cycle, where it clearly can be seen that most of the current is being consumed during the Wi-Fi operation. So when the module is turned on and when the data is sent to the remote data warehouse. But during the deep sleep, we can see that a little current is being consumed. Within the project, we also developed a calculator that allows you to evaluate the battery life for a specific monitoring system. In this calculator, it is possible to define different system operation states and specify the time each of the state takes with the according current consumption. In our case, depending on the measurement intervals, the monitoring system can be powered with standard AA batteries and run for several months. The monitoring system was also successfully installed in the field, where it was locally assembled in Indonesia and used for rapid surround bee colony monitoring. On the left side you can see the Hive installation process and the Hive and the data that was sent to the data warehouse. This was just a brief description of one of the SAMS Hive monitoring systems. Thank you for your attention.